Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on tNavigator, a reservoir simulation software, which is very useful. And today's topic is about LGR or local grid refinement. It's a very good feature for us to use in reservoir simulation, especially if you want to get a more focused, a more detailed evaluation on a particular area. Okay, so again, I will use an example case from tNavigator. So hopefully we can learn many things from this case. Okay, so I'm opening a LGR case from tNavigator sample. We are currently looking at a two-dimensional map, especially it's about the pressure. Okay, so it's pressure map. All right. You can also click this one to get a 3D view. Okay, we can move the time slider. Okay, and you can see the wells out there. And again, of course, we are looking at the user interface, but behind this visualization, of course, are files. Okay, like the grid are taken from these files, the properties are taken from these files, the region, solution, summary, and the well schedule are actually taken from those files. All right, so in this case, we will look at the user interface as well as the script or the file. All right, so this is the map that we have. You go to here, okay, and 2D map. And here you can see LGR at current step. You can change to do not show at current step or show all. But we cannot see, we cannot look at any LGR right now. Why? Because we haven't shown the grid lines. So if we go back to at current time step and we show the grid lines, easily we can locate where the LGR is. All right, so you can see there are LGRs. Okay, usually the normal cell, the size is here, but for the LGR, we can see a smaller cells, right? Smaller cells. So for this one, particularly this one cell is divided uniformly into 9 cells. One cell divided into 9 cells. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, you can also look at the 3D view. Tick on this one, grid lines, and you can get the grid lines. All right. The same thing if you change to saturation of oil, saturation of water, and so on and so forth, including initial, right? So those two are the LGR, right? And let me go to saturation of oil again. So, all right. But before that, let's go back to 2D. And you see here in this LGR, we have uniform smaller cells, right? Smaller cells with uniform size. But if we go to the left LGR, the size are different, all right? This one different from this one and different from these columns. Why? I'm going to explain it later. All right, so let's go to the files. And this is the mother file, LGR model data. All right. Nothing so special actually. We have run spec, start, metric, the unit, right? Unif out, oil, water, gas. All right, the component, the phase, this gas, all right? This is for the case. It's not the main thing in our particular video right now. No echo, implicit, diamonds, rect dims, step dims, everything. No, nothing special so far. But here we have this one, the first keyword, LGR. All right, so if you want to understand what does it mean, all right, you need to go to the manual. All right, you need to go to the manual. And for this particular keyword, actually we want to tell tNavigator that I will have two LGRs. All right, the maximum numbers of cells in each LGR is 100,000. All right, 100,000. So I have two LGRs, the first number and the maximum number of cells for each LGR is 100,000. All right, but if you look at the tNavigator manual, if I'm not mistaken, we can follow the default. All right, for this particular keyword. All right. Okay. Maybe I'm going to go back to the manual first. I want to confirm. Okay, so I will clarify. So the first number, all right, this two is the maximum number of LGRs in the model. So I basically have two LGR. So I just set maximum number to be two, but of course I can increase the maximum number of LGR, right? And the second value, the second number here, 100,000, is the maximum number of cells in each LGR, right? So the maximum number in each LGR is 100,000. And the third one, 0 here, is the maximum number of amalgamated core cell. And the fourth number is the maximum number of LGR amalgamations. And lastly, the maximum number of LGRs in any amalgamation. But in tNavigator, all right, this specification actually is not obligatory, all right, because the memory is allocated dynamically, all right? So, yep, for this one, you can just follow the default by tNavigator, okay? Again, I recommend you to go back to the manual itself. And if you look at the manual, actually this specification is not mandatory, all right? It's not obligatory. All right, and then we go down grid, all right? This is for the grid section, init for initialization, and here, all right? Of course, we have include this one, the grid. We include the grid into the model, of course, but the LGR will be defined by using this include file. So the name of the file in this case is lgr underscore model underscore lgr. So we are going to go to this file later. All right, and then props, stone, and then for PVT for relative permeability, nothing special. Region, all right, this is for the region. Solution for initialization, and then summary, and then the schedule. All right, so the only different thing in this case is here. Oh, sorry, not that, this one. All right, the main thing that will define the specification of the LGR will be defined by this file. All right, so let's go to the file. We can find that in under the grid and this one. All right, so this is the main thing. If you want to have LGR, you use the keyword carvin. And after you specify the LGR that you want, you close with nfin. All right. So I have two LGR. So I have two carvin, this one and that one, and two nfins, that one and that one, because I have two LGR. All right. We go to the first LGR. I name the first LGR LGR1, and I name the second LGR as LGR2. All right. And we have for each LGR, we have specification for X layer, for Y layer, and for Z layer. All right. For X, we have two numbers, the first and the second. So what does it mean? Let me maximize this one first. All right. All right. So here I have 56 to 69. All right. What does it mean? 56 here, you can see here, and you can read here. It's the 56th layer in X direction. And 69 here, the second number is this one. So basically, I want to set my LGR at X equal to 56 to 69. That's why you find the LGR here, 56, all right, to 69, okay, for X direction. And the third and fourth number are for Y direction. So we have 53 to 66. Let us check. Here, right? Sorry. Here, starting from there. 53, you can see 53. And if we go down to 66, basically just like what the file says. All right. 53, the third number, to 66. And the fifth and sixth number are for the Z layer. So it means that I have the LGR for the first, starting from the first Z layer down to 11th Z layer. All right, so it's easy. For X, 56 to 69. For Y, 53 to 66. And for Z, if we go to 3D, we have here how many layers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for Z direction, I want to set my LGR for starting from first Z layer down to 11th Z layer. All right. So I have the LGR, the first LGR, the LGR1 like this. Okay. Again, it's easy, right? And then I have 42. What does it mean? I think I will go to 2D map. All right. So if you count from 56 to 69, you have 6, 7, 8, 9, 60, 61, 2, 3, 4, 5, 6, 7, 8, 9. You have actually, or you just count 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You actually have 14 cells starting from 56 to 69. But using LGR, you will have more cells in X, Y, and Z direction. And we specify that using this 1, 2, 3, 4, 5, 6, 7th number, 42. All right. So basically, I originally have 14 layers in X direction from 56 to 69. Now I will improve the number of cells up to 42, 42 cells. So you can count 1, 2, 3, all right? And this one is 14 for 14 multiplied by 3, 42. So you have 42 cells. You can count, but I guarantee it's 14 multiplied by 3, so you have 42 cells. For X direction, the same way with Y direction. You originally have 53 to 66, you have 14 layers. You want to multiply it to 42 layers. And from 1 to 11, the Z layer, the Z direction, you multiply by 3, you divide each cell into 3 sections uniformly. So you have from 11 layers, now you have 33 layers. Easy, right? So this is the name. This is the X layer from 56 to 69. All right, and then 53 to 66. That's for the Y direction. All right, and then for Z direction, starting from the first to the 11th layer. All right, and then for X direction, you want to have 42 cells, 42 cells also for Y direction, and 33 cells for Z direction. All right, so the 100 is the maximum number of wells that the LGR1 can contain. So LGR1 can contain wells up to 100 wells. All right. By the way, if we move the time slider, we can see 1, 2, 3, 4, 5, only 5 wells. But the maximum number of wells that this LGR area can contain is 100 wells. All right, so far so good. And actually that's it. That's it for the first LGR. So if I close with slash, you have to use slash, right? And you close with nfin, it means that all the LGR, all the cells will be uniformly sized, all right? They will have uniform size. That's why if you go back to 2D, the size of the cell, they're the same. They are of the same size, all right? But don't forget we have two LGRs here, and the second LGR looks very much different. Why? Because we use different setting here, and it is a little bit more difficult. But of course, we still open with Carvin, and then we name it as LGR2. The setting here is absolutely the same. So we set the LGR from 28th layer to 33rd layer. For X direction, you can confirm that. So it's 28, 29, 30, 31, 32, 33. And then for the Y direction, starting from 53 up to 66. 53, sorry, not that one, sorry. 54 to 60, all right? So 54, 55, up to 60th layer. But for the Z direction, we set the LGR for all Z directions. So starting from the first layer down to 11th. But for X direction, you have originally 1, 2, 3, 4, 5, 6, 6 cells. But now you want to focus, you want to be more detailed, you want to add cells. All right, you want to multiply the cells from only 6 cells. Now you want to have 13 cells, and you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, and for the Y direction, we can count again. Originally, we only have from 54 to 60. All right. 1, 2, 3, 4, 5, 6, 7. But now we want to have 21 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And then 13, 14, 15, 16, 17, 20, sorry, 18, 19, 20, 21. All right. 1, 2, 3, 4, 5, 6, 7. Yeah. Basically, it's 7 multiplied by 3. Very easy. And the same thing for z direction. So originally you have 11 layers. You multiply them, you will now have 33 layers for z directions. And again, this LGR2 can contain up to 100 wells. And then you close with slash. But now you have different setting. If you close with nfin directly, all right, just slash and then nfin, you will have uniform size cells. But now you have different size. All right, and we can make that using this setting nx fin for x direction. If you want to set different setting for y direction, then you will use ny fin or nz fin. All right, but now we only use nx fin for this case, so we only have differentiation for x direction. For y and z direction, the LGR cells are uniformly sized. Okay, so I'm going to delete that. All right, now we have 1, 2, 3, 4, 5, 6. We have 6 cells. They have different meaning. All right, so the first one, 3. I have value 3. So what does it mean? So you need to follow me carefully because yeah, sometimes it can be a bit confusing. So for LGR2, you need to focus only at this one, LGR2. All right. You have 6 layers, right? From 28 to 33, 28, 9, 30, 31, 32, 33. You have 6. So basically the first one is the number of LGR cells for the first layer. So you have 3 and 2 for the next or the second layer. Now you have 2, 1, 2. For the first one, you have 1, 2, 3. Okay, so we only focus on x direction because we set nx fin. All right, focus your eyes on x direction. So for the first x layer, we have 3 cells. And the second, we have 2 cells. And the third, we have 1 cell. That's why you can only have 1 cell here. There is no separation, all right, for this area. And then we have 2, 2 again, and then 2 again here. And lastly, we have 3, 1, 2, 3. So very simple. That's for NX fin. Of course, you can set NY fin, but I think I will leave it for your exercise. All right. I'm going to close that. And don't forget to close with slash. All right. And then, yeah, HX fin. So basically, HX is for the size ratio. All right. But it's dimensionless. So it's just a proportion. So we have 1, 2, 3, 4, 5, 6. Because we have 6 numbers here. So the first here, the first setting here, it's for this 3. And the second one is for the 2. And 1 for 1, 2 for 2, 2 for 2, and lastly 3 for 3. So focus on this one first. We have 2, 1, 3. So this is for the size ratio of these three cells. So here you can see here, this is 2 in ratio, 1 in ratio, and 3 in ratio. So that's why the last cell here has the largest dimension, has the longest in x direction, because the ratio is 3. So the length of this cell is 3 times longer than this cell. And the length of this cell is 2 times longer than this one. Because the ratio for x length is 2:1:3. And in the same way, for the second layer here, you have 2:1 proportion. So that's why this is longer than that one. And for the third, we only have 1. So there is no ratio. It's just 1 because this one is 1. And then again, 2:1, you have this one longer than that. 2:1 again longer than that. If you want this to be shorter than that one, then you can just change it to 1 and 2 like this. All right, and then this one, 2, 1, 3 again. So basically, HXFin, we use that for the proportion of the length for X direction. And then we close with slash and then close with nfin. And pretty much that's all for the LGR setting. All right, don't save. So it's just like that. So you have grid, and then you need to add another file to describe the LGR. Okay, so you have this LGR file under the grid section. So under the grid section, you have the grid itself, this thing, right? And then you have the file, the include file for the LGR. All right. Okay, pretty much that's all, I think. Yeah, you can just like focus and you can see the value for each cell here. Okay. And then we can also go to user map. Okay. And then here, if you want to focus on the LGR, you can type in grid underscore ID like this one, apply to map. All right. All right. Okay. So you see. So by using this grid ID, I just want to say to tNavigator that I have true ID, two ID, I mean, two ID of LGR, the LGR1 and LGR2. Okay, that's why they have different color. All right, and another thing, you can also go to 2D map and then user map, right click, create, and then you type in grid underscore ID, and then this one, 2, and I equal 1, and J equal 2, and K equal 1. All right. Sorry. to isolate this particular cell here. Okay. Before, if you go to pressure, sorry, if we don't have this user map, okay, let's, yeah, can we remove this one? Or if we remove this one, yeah, we basically do not know the identity, right? But by using this, create, then same this one, you can isolate the particular cell here. So grid ID 2, all right. Actually, although the name of this LGR is LGR1, as a grid ID, it's the second one because the first will be this one, the original. All right. And then I say I equals to 1. It means I want to isolate the first X layer. All right. And then J equals to 2. So I want to isolate second J layer. That's why you have this located at the first X layer, but at the second J layer. But for K equals to 1, that's why we get that in the first K layer. But if I change the ID now 3, I isolate this cell. All right, because as I said before, ID1 is the original cell, ID2 is the LGR1, ID3 is the LGR2. All right, and for the IJK, I think you already understand. You can also change it to K, I mean to 3, you get that. And then if you want to change it to 5, then you go to this particular cell. All right. And of course, you can, as usual, right click and add well. All right. And you see the local grid is LGR2 with the X, Y, and Z. All right. Just as usual. Okay. And if you want LGR, click add well. All right. And then, yeah, you can click run and you will have the calculation. All right. Of course, by adding the well like that, now in the file, you will have com.md and you will have well spec. All right. And you will find that in user flow folder. So if you go to files, here you have user because this is actually a new well that we add. Okay. Here. Okay. So the name of the well is here, WU1 underscore 1. So this one, this well, and it's located at LGR2. Okay. And for the IJ here, the face oil, and for the COMDAT here. Please notice that you have L letter here for local. Okay. Basically for original or for normal well, you will only have well spec or com.md or comdat. And as usual, you have comport and conprod for the production setting and just the date of starting production. Okay. And what else we can have? And let's see if we want to make cross section here, create cross section. I'm going to use point selection. This one, that one, that. You can also check the 3D. So you have like that and close and go to 2D. Here, roof, go to cross section. So you see, you can find the well and you can see the LGR. Okay, let's say if we put the cross section, go back to roof. Now the cross section, I want to expand, delete first. And I want to start from the normal cell. Starting from here, entering the LGR, and then close at normal cell again. If you go to 3D, it will be like that, and close, and then go to 2D, and then go to cross section. You see, this is the normal size without LGR, and this is the LGR area with local refinement, local grid refinement. Okay. And of course, as usual, you can right click and add well, and maybe you want to drill your horizontal wells guided by the LGR. Perhaps if you want that, you can do that. Okay. And by the way, you can also hide the LGR by unticking this one. You will have the original view. All right. Let's go back to roof. Okay. All right. Basically, we can't see different or changing color because yeah, we still look at the roof. Okay. But you can go to min, all right, and max or sum, be like this, average. So you can see the difference from LGR1 and LGR2. All right. Okay, I think that's all. And the last thing, I think, why do we need LGR? Okay. Yeah, basically, you want to have more accurate calculation in that particular area. Sometimes you want to get better calculation, more detailed calculation in area surrounding the well, all right? Either for producer or for injector, or maybe you want to evaluate in areas surrounding faults, all right? Surrounding a particular area, maybe because the area will be invaded, will be swept by water from water flood, all right? Maybe you want to isolate or want to analyze area to which CO2 plumb will go. And of course, areas surrounding the well, surrounding the injector, surrounding producer are basically the most popular area for LGR calculation. All right, but as far as this video is concerned, we want to show you how to use the LGR in tNavigator. And you can see it's pretty much doable. It's not that difficult. And hopefully all the learnings that we learn here will be useful for our future exercise, future work, and future learning. All right, so I think we can call it a day. Thank you so much for watching. I hope this video is useful and informative for all of us. And I'll see you in the next tNavigator videos. Thank you.